Okay. Who in here likes roller coasters? Anybody not like roller coasters? Terrified? That would be in the me category. I don't do roller coasters. You guys know the comedian Kevin Hart. Maybe not. Let's take a look at this video. What he does is how I would react, okay?
Are you serious right now?
I'm serious. You're good.
I'm a grown man.
Let's go. If he's straightforward, you'd be invited. Come on, you have to do it. Come on, we're still looking good. Come on, we got it.
Lock me in. Lock me in, man. Come on, drop it in. No, push it further. Push it farther.
Do what?
Okay, so I want to show you the other parts here. Now, just a reminder, you see that hill. That right there. This is why I don't do roller coasters. But this is what we're going to use to investigate our next sort of mini unit here. So what we're going to ask is a writing prompt. Thinking about when he gets to the very top of the hill, you know, they pause for that split second, that's sort of like, that's intentionally done to make you freak out, like what's about to happen. And then again, watching him go down that hill. And as fast as they're going at the bottom of that hill. So between the very top of the hill and the bottom of the hill, what you're going to do is answer the prompt. When does the roller coaster have more energy? At the top of the hill before it starts moving, that means the velocity is 0, it's not moving yet. Or at the bottom of the hill where it's moving at a greater velocity. So what you're going to answer is, I believe the roller coaster will have more energy at the top or the bottom because, and provide your reasoning, why do you think it has that energy greater at the top or the bottom? So I'll give you about 2 minutes to do a silent think and write. That why is pretty important. Because the next couple days, we're gonna be answering the same question as you learn new bits of information. So we're gonna see if your why changes. About 15 seconds. Appreciate you sitting quietly while your peers are finishing. As you wrap up your thought, go ahead and switch back to your composition book, your interactive notebook on page 3. We're going to dive deep into our kinetic and potential equations today. Be able to answer that question. Is it actually more energy at the top or the bottom? So go ahead and write these equations in a notebook, and we're going to label what all of these variables actually mean. Your kinetic energy, KE, is measured in what? Joules, there you go. This M is mass, and that's measured in what? Grams, good. G for grams. V, this is kind of a new one, is velocity. Now, we've actually got an entire unit on velocity a little bit later this semester. So just for this equation, what I want you to think about velocity is how fast it's moving. And velocity is measured in meters per second. So KE only has 3 variables, this equation. PE's got 4. Let's take a look at these. PE, potential energy. Also in joules, all energy is measured in joules. Then we have our M, mass, which you've already said is grams. We have G, which is a new one. G is the acceleration due to gravity. Also, another idea that we're going to be covering later on this semester, acceleration due to gravity is how fast something falls towards the earth. Now, acceleration due to gravity, it doesn't matter where you are on Earth, you will follow the same acceleration. And that number is the number you need to memorize, is 9.8 meters per second squared. So what is G? 9.8. What is G? 9.8. I'm gonna ask you multiple times during class and tomorrow. What is G?
9.8.
Good. And then H, this is the last one, is height. And just like length, it's measured in good meters. So we've got our two equations, kinetic and potential. And we're gonna use these to figure out whether that roller coaster is faster at the top or the bottom. Once you've got this copy, you go put your pencil down so I can erase it. Okay, go ahead and open up your step journal again. Okay, so let's do a little investigation. If you notice on your table, you've got a bucket with materials. So go ahead and lift that black paper and take a notice. You've got 2 meter sticks. You should have a car. Each table has a different car that has a different shape, so they're all a little different. You have a scale. You've got some calculators, and you have some Hot Wheels tracks, right? So go ahead and pull your materials out. I'm going to make a data table because I need to find the potential energy. So I'm gonna have my data table, potential energy. If I am looking for my potential energy, what do I need? Looking at the equation, what do I need? I need my mass. What else do I need? I need my height. And I need that's G. So I need my gravity. So your data table can look a little bit different if you needed to. This is just for me to organize my thoughts. For potential energy, I need those 3. So those are 3 bits of information that I absolutely need, right? So let's take a look first. Give you a second to draw your table. I am a little bit OCD with my lines, so if you are too, I will give you a couple of rules here. You don't use it, that's okay. Whenever you needs it, no problem. So I'm just starting from the top. I gotta collect my mass. So based on all the materials on your table, how do we collect mass? With a scale, right? So go ahead and turn it on. Before you put anything on it, turn it on. Make sure it's black. Press the tare button and make sure it says 0. If it doesn't say 0, press tare. It should say 0. If it says 0, then go ahead and put your car on it and record your mass. It should be in grams. Let's just say it on the side. So we've got our mass. And what's G? What's G? What's the number for G? 9.8. So I don't have to calculate that. That's already given to me. 9.8. Right? So I've got 9.8. Okay. Height. How in the world do we get height? What do you think? Yeah, let's get the meter stick out, right? So when I get my meter sticks out, remember that the smaller numbers go on the bottom, taller numbers on top. Make sure you're using the centimeter side, right? So we need, what are we measuring? The height of what? Of the car? What is the car going to be on? The ramp. So go ahead and build your ramp. You could use one, you could use all 4, you could use 2 or 3, however long you want your ramp. Yeah, just slide together. However long you want it. Okay, so consideration, you and your teammates are going to decide whatever height you would like the ramp to be, okay? Now here's the thing, if it's high, don't make it go straight down because sometimes the car will fall off. So you want to have it, somebody's going to end up holding it so that it goes actually down the ramp, okay? So you pick whatever height, it could be in the bottom or the top, in the middle, wherever you like, pick a height, record your height.
Just do it.
Yeah, just this far.
Not to see if it works. Why are you back down?
So once you've gotten your height, go ahead and record it, and then take a seat. So we're going to do a small calculation really quick. Got your height? left table has got your height.
Good, almost done. In the middle, 65 cents.
Okay, so here's what you're gonna do. I'm gonna kind of use this side space as my sort of calculation space. Make my table a little shorter here. Okay, so let's say, I take 31 centimeters. I don't know, I'm just being kind of random here. These are meter sticks. Our standard unit of measure is meters. So I need to get my 31 centimeters to meters. So you get 100 centimeters equals 1 meter. So what you're gonna do is move it over to 100, like, you make the decimal to the 100 spot. So I would move this over twice and get 0.31 meters. So whatever your centimeters are, however much your height is, go ahead and move that decimal over, and that's gonna be your height. So mine would be 0.31 meters. So from here, I should have everything I need to calculate my potential energy. M times G times H. So I'm gonna do my calculation, you're going to do your calculation with the calculators at your table. So I'm just gonna set this up, I write my equation down, I substitute my numbers. So P equals M 37 times G 9.8 times H 0.31. And I'm gonna take my calculator and I'm literally just gonna multiply across. So if you're doing the calculation, make sure you and your partner are the same number since you're all doing it at the same table.
We go M, G, H. So what's the total? 230, 23. 0.8. Wait, so 203.8.
So we've got our potential energy, right? So that means at the top of whatever your height is, your car, that's how much energy your car has waiting to be dropped, okay? So now we need to figure out the energy at the bottom, which would be the kinetic energy. Whew, scared me there for a second. So we need to do our kinetic energy equation. What do we need to find for kinetic energy? Mass, which we've got already, and velocity. So here is where it gets a little tricky. We're looking for our velocity. Velocity, the way to calculate velocity, I'm going to put it over here, is distance divided by time. Okay, so I'm gonna add this underneath velocity to do a separate calculation. Distance divided by time. So go ahead and set up your ramp, just like you did for potential. Now this team, you guys are using all 4 pieces. And that's okay if you're using less, or if you're using 4, that's fine too. So if the 4 pieces is my distance, what I'm gonna do is I'm gonna lay it flat, and I'm gonna measure how long is this in meters. So again, make that conversion. If you have 100 centimeters, that's 1 meter. So go ahead and measure how long that is.
Give me the
Good catch.
At the very beginning. This was just shy of 20. That's 30, so 120. You said distance is 1.2. Oh,
I think it's this thing.
yeah, these are the centimeters. These are also centimeters. They have to do 1.02 This is
No, you could be more accurate.
If you have your distance already calculated, go ahead and take your meter stick and hold it up. So I see that you're ready to go. 2 groups ready. 3 groups are ready. Again, when you're ready, hold up your meter stick. Yeah, you can round that up. Okay, so it looks like every group is ready. So we've got our distance. Now the last thing is we have to calculate time. So time of what?
Takes the travel the track.
Good, how long it takes to do the track. So here's the thing. I need 1 person at each table to have a phone, okay? Now, this is gonna be a little bit tricky because the car moves fast. So what some students will do is they will either sit and, do the timekeeper and just try and press it, or you can actually record it and it'll show you the time if you do a slow motion video. So whichever you prefer, if you would prefer to just time it with your finger or watch the video and calculate the exact time, either one is appropriate. So choose whoever's got your phone, and then go ahead and calculate it. How long does it take to drop from that height that you chose?
Are you ready?
It's gonna be straight.
Yeah, it has to be. No, it can't be like this. It has to be like this.
And come over here and measure the, go ahead, put it like that. I think around here.
Are you ready? Oh, you got the ice?
Ow.
Alright.
Ready?
Oh, yeah.
Hold up, somebody put my clamp in, so it doesn't, no, put it in the end. Right there. 3, 2, 1, go. 3, 2, 1, go. Okay, that was fast. Stack up 17 seconds. Flopped over. You want to try it again? Yeah. Hold up.
Once you've got your time set, go ahead and take a seat.
Let's try again. Oh, it's the wrong way.
And it stops at 14, so 3 seconds. Yeah, 14.
It's 3 seconds in slow motion.
Boost the middle a little bit. There you go. Okay, so let's take a look. If we have our distance, and again, these are my numbers that I did when I was doing this exercise earlier today. If we have our distance in meters and we have our time, you divide distance divided by time. And yeah, you're gonna get weird numbers, that's okay. Then my number, my velocity is going to be 1.71 meters per second. And you can see where the meters and the seconds come from. So go ahead and divide that. Make sure everybody at your table has the same calculation, distance divided by time for your numbers.
So that's the velocity.
8 Okay, so now we're gonna get to the kinetic energy equation. And this is probably the second most missed equation of the whole year, because people do, small errors. So I wanna make sure I explain this right. I've got mv squared over 2. Y'all remember PEMDAS from math? What does the P stand for? E, M, E, A, S. So we're starting off, we don't have parentheses, but we do have an exponent. You've got to do your exponent first. So again, I'm going to use my numbers if you want to write this in your numbers. I write my equation, and then I substitute my numbers. So my M, my mass, is 37 grams. My velocity is 1.71 squared over 2. So if you want to write your substitution really quick, I'll give you about 10 seconds. Put your numbers there. Mass times velocity. Sharing some questions about velocity.
So 100 to where?
Okay, so here's where a lot of people get mixed up. What students end up doing is they will just go straight and multiply 3 times 37 times 26 squared. You have to do the parentheses first. So take your velocity, put it in the calculator, whoever's got the calculator, watch your neighbors so they do this correctly. Put your velocity in the calculator. There's actually a button that says x squared. Press x squared, and it will square for you. Yours is right there, yeah. And yours is right at the top middle. Yours is on the side. Yeah. Y'all got it? X squared? So that's x squared, right? That's your v squared here. After you have this number, then you multiply your mass. So take what you got times your mass. Times your mass.
So put the worksheet and
So after you have multiplied your mass, then divide it by 2. So take whatever that number is, it's going to be a weird decimal, that's okay. Divide that by 2. That is what you're doing in math. There's a reason why you're doing it in math.
Okay, so 32
That's the number at the top. Now divide it by 2. That's your answer.
They got the same here.
How you guys doing? What did you get for your independence? I usually round it to the second decimal. So would that go up or down?
I need to find out the number for everything.
To share. Or
Okay, so we have now officially gotten our potential energy and our kinetic energy. So here's the kicker. Where's my red pen? Ready for this? That was trial one. That was trial one, and you know for a good science experiment, we have to do more than one trial. So we're gonna do 3 trials.
Are you saying?
Now here's the thing, what I want you to keep the same. You're keeping the same car, that means your mass doesn't change. So you can carry around your mass all the way down your sheet here. What I also don't want you to change is your distance. So how long the track is will not change. So make sure that goes all the way across. What else doesn't change? There's something really important that doesn't change.
gravity.
Your gravity. We did not change planets, we're still on Earth. So your gravity should also stay the same, okay? What will change, the only thing that you're changing is your height. So you had a specific height. Now I want you to change it. It could be higher or it could be lower, okay? So you have, what I recommend is to get your height changed, calculate your time, and then do your calculations. That way you don't run out of time, okay? So you've got just about 10 minutes, a little bit less than 10 minutes to get your numbers. If you don't finish calculations, that's okay, but try and get your numbers.
So the distance will be the same as the one.
Remember, if you're going high, make sure that you have that curved ladder so that it actually rolls. Otherwise, it'll just fall. You ready?
After that, that's what we did first.
Everything else stay the same, right?
Yeah.
That's not true.
You've got about 3 minutes to collect your data. Make sure you get your data, please. Two more trials, 2 different nights.
No, it didn't. This is 1.30. The 1.30. Or are we gonna do the full thing? Let's do the full 100.
You've got 1 minute to collect your data. 1 minute.
Ready?
Zero to
I think it probably is, but this
Why don't we do for 90? Or do we do
Okay, yeah, right. Ready?
Yeah, 93. And then it's there. We're later. That was so fast.